This is a joke. Specifically, it's a English-Japanese bilingual pun. And if you give it to AI, you'll get a lot of varying but not correct interpretations of what this means, while giving it to humans will almost always give you the right answer. AI is, of course, changing all the time, and so by the time you're watching this video, it might be able to understand this joke. But by starting at the details of how this works and generalizing from there, I'll try to build a framework of 3 different things that AI will always have trouble understanding, no matter how it advances in the future. And we're going to try to build that framework using some postmodern philosophy and cyberpunk anime. But I'm getting ahead of myself. To start, we just need to explain this joke, which as we all know, will not at all affect how funny it is. Okay, so we're going to need some baseline knowledge about Japanese to have this make sense. In order to understand Japanese, you need to be able to read 3 separate writing systems. Or maybe 4, or... Okay, there's 5 different things you need to be able to read to understand Japanese. But for now, we're just going to focus on one called kanji. Kanji are logographic characters, meaning they represent concepts instead of sounds. So, for example, the word to read is yomu, and in that word, yo is written using this character for reading. But in other words, like tsundoku, it's read as doku instead, but it still carries the concept of reading. The first character here vaguely means pile, and this character means reading, so it's a pile of unread books. Incidentally, this is one of my favorite Japanese words. The connotation is that you have a pile of books you're planning on reading, but you keep buying new books faster than you read your existing ones, so the pile never shrinks. Lately, I've gotten into the habit of stacking books I'm planning on referencing in videos into their own tsundoku piles, which I find rather entertaining. Anyways, in addition to using this ability of kanji to be pronounced different ways in different words, my joke also uses kanji in a particular poetic way called a yoji jukugo, or 4 kanji idiomatic expression. Because kanji represent more general concepts than specific words, these phrases can express complicated ideas in a very compact way. Common ones you might see are things like shichiten hakki. The individual symbols mean 7 fall, 8 rise. So the meaning of the phrase in general is something like, it doesn't matter how many times you fail, it matters how many times you get back up afterwards. Or keep going no matter how tough it is kind of vibe. Another example is dokusho shoyu, which means by reading books, you can count the wise philosophers of the past as friends. Now, amongst these poetic pieces of wisdom, we have my yoji jukugo. Reading the kanji one by one gives this morning, every morning. You could interpret this to have some poetic meaning, something about atomic habits or something like that. But unlike normal yoji jukugo, the true meaning of this one is only revealed when it is pronounced. The first 2 characters can be read together as kesa, and the second 2 characters can be read as mayasa. So together we get kesa mayasa. So yeah, the whole explanation is just a setup to say kiss my ass in English. I never said it was a good pun, just that it existed. Now, I've had multiple bilingual speakers see this and immediately go, Kesa mayasa? Oh, that's a dumb pun. But plugging this phrase into top-of-the-line AI chatbots like ChatGPT, Claude, Gemini, and DeepSeek all give a variety of confused results. Specifying that it's a pun just results in the AI insisting that this morning, every morning is funny, and even spelling out that the joke results from the process of sounding out the words in Japanese and then interpreting those sounds in English rarely gives anything resembling the correct interpretation of kiss my ass. So why does AI find this so hard? This is one of those questions that has a lot of different ways you can approach it. And because machine learning, and LLM specifically, can be so opaque, it can be hard to understand at a satisfying level. So I'd like to start by saying that, from the onset, this problem is unfairly harder for the AI than it is for humans. The nature of typing this prompt into a chat box already strips essential elements that humans use to understand each other: context. In the world of Google Translate and easily accessible online dictionaries, it's easy to assume that the problem of translation is basically solved. And while this might be true for simple words or phrases, translation in context is still quite challenging. For example, let me show you something that I was confused by. This is from the show Vinland Saga, which is a drama about Vikings that goes through decent amounts of length to be relatively historically accurate. So my first reaction to seeing this was, why does this Danish guy in 1014 know about a Japanese board game that doesn't exist yet? And the answer to that, instead of just being a result of bad writing, involves the entire process of inspiration and adaptation that eventually led to these English subtitles I'm reading. The Vinland Sagas are a collection of mostly historic Norse tales about the first Europeans to settle Iceland, Greenland, and the Americas, which they called Vinland. Japanese author Makoto Yukimura took part of that story, combined it with other historical events and local folklore, and created a comic called Vinland Saga. This comic was later adapted into an anime TV show, and the clip I showed was the English translation of that show. To explain that translation, we're going to have to take a step back and look at some features of Japanese that English doesn't have. I mentioned how kanji are pronounced differently in different contexts. This makes Japanese more difficult to get literate in, though I don't think English speakers necessarily have a right to complain about that. So, when learning Japanese, instead of having to memorize thousands of characters right away, you instead learn a separate system that is closer to an alphabet, where each symbol has a phonetic component but no inherent meaning. Books written for children will be written almost entirely in this system, which greatly reduces the amount of symbols you need to memorize. As you get better at reading, it becomes nicer to use kanji instead. It's a lot faster and can disambiguate homophones, which are much more common in Japanese than in English. But when you encounter a kanji you don't know, it's very annoying to look it up. So, writing targeting intermediate readers will use what are called ruby characters. Basically, this involves writing the phonetic reading above the kanji that gives the specific phonetics for the kanji in that context. You see this in basically every kanji that shows up in writing targeting teenagers. And as a side note, it's one of the defining factors of what makes something shonen or not. This format of writing the meaning and pronunciation of a word separately has a bunch of other uses as well. So, for example, the word for house in Japanese is uchi or ie, and you write it with this character. But in this comic, they use the character but then phonetically write sore, which means that. So what this means is that the character is just saying that, but he means that house. By using ruby characters in this way, Japanese can have characters speak more vaguely, but then convey more specific meanings to the reader. And that's what's happening in our Viking story. The character says battle isn't like, and then we see this, which says he's saying the word Neffeltafel, but what he means is shogi. Neffeltafel is a strategy board game Vikings played at the time that involves trying to manipulate an army to kill or escape with a central king. Shogi is also a strategy board game about manipulating an army to kill a king, and is popular in Japan in the modern day. The author assumed that most of his readers would not know what Neffeltafel is, so he used ruby characters to simultaneously communicate that the character is saying Neffeltafel, and Neffeltafel means something similar to shogi. When the comic was adapted into a show, you can't verbally communicate two things at the same time like this, so the showrunners made the reasonable decision of prioritizing their audience understanding the scene over it being lore accurate. So they just have the actor say shogi in Japanese. Then we finally get these English subtitles. If you listen to what the Japanese is saying, you can hear he actually says shogi. And so putting shogi in the subtitles is an accurate translation. If we just take the Japanese script and plug it into something like ChatGPT, we basically get the same thing. But we, knowing additional context of both the languages and mediums involved, can see two other translations that I think are better. One option is to go all the way back to the original source material and use the Norse term Neffeltafel. And in fact, this is extra fitting because Neffeltafel is asymmetric. Only one side has a king to defend, which matches the metaphor's use in the story better. Alternatively, we could look at the intent of the use of ruby characters in the comic. Neffeltafel is being used to talk about military theory and tactical thinking, which in Japanese media is often a role filled by shogi. But shogi is not very popular outside of Japan, so an English speaker isn't necessarily more likely to know shogi than they are Neffeltafel. I personally know a number of people who have played Neffeltafel, but not shogi. Instead, in English media, chess is usually used as a proxy for tactical thinking in the same kind of way.
Ah, the Fibonacci opening. Very interesting. You're just gonna mess with me this whole time, right?
Yeah.
So I would argue that translating shogi into chess is, within this context, a much better translation than what AI gave us. The subtitles I originally showed were from the company Crunchyroll, but different companies that translated this show into English did it different ways, and we can see both of the things I said were better than shogi showing up in the English dubs of the show.
I don't need any of your bullshit. If you know how to beat him, why didn't you take him on yourself?
A battle is not the same as a game of Nefertafel, boy.
Nefeltafel and chess aren't translations of the word shogi. An AI would be correct to always just translate the word shogi into shogi. But by digging into the context of why that sentence exists like that, and considering who the audience this translation is intended for, we can give a better translation than the one that's literally correct. And that's something AI can't do. You'll also notice that in all three of those translations, the kid swears.
I don't need any of your bullshit.
But Japanese doesn't actually have any swear words, or at least not in the same way as English. So all those translators took into account the character that's saying it. Having this angsty teenager say, that's rubbish, doesn't make sense in context. He would definitely be cussing. But again, it's a less accurate translation unless you know the context of who that character is, and the context of the features of the language in general. In the afterword of the English translation of the Mandarin book The Three-Body Problem, the translator Ken Liu has this to say: "The obvious difficulties, such as the differences in linguistic structures and cultural references, are actually relatively easy to resolve, but there are more subtle issues involving literary devices and narrative techniques. Overly literal translations, far from being faithful, actually distort meaning by obscuring sense." In my opinion, this is the biggest hurdle that AI has for translation. If you look at translations for individual sentences on ChatGPT or Google Translate, they're going to be pretty good, but it's not good at translating full bodies of work, things like an entire book or show, because it isn't able to dig in and have this more contextual understanding of how the language is being used. On the other hand, humans can communicate with just context. The most extreme example being Nicaraguan Sign Language, where a group of children who didn't speak any language got together and, through repeated interaction and remembering the context of those interactions, dynamically developed an entire language over the course of a few years. Going back to my original joke, you can see some similarities. If you're in my apartment and see this sign, you have a bunch of context I'm not giving to the AI. You can see the other Yoji Jukugo and are therefore more inclined to interpret this poetically. You know me and my sense of humor, and therefore are more likely to suspect it's a pun. And you're fluent in English, and therefore will default to interpreting things as English much quicker. All of that's important to determining the meaning of the phrase. So, with that in mind, let's try to give AI that additional context and see if it can understand it then. Here's my updated prompt I'm using, and I sent that to a bunch of different LLMs, and some of them got the correct answer. But only some of the time, and it depends on the phrasing. Interestingly, if at any point in the prompt I mention bilingual pun, almost every LLM can get it almost every time, which to me implies that AI knows all the information it needs to solve this, but for some reason isn't using that information unless specifically prompted to. And to understand why that is, I think we're going to need to dig more into the details of how specifically LLMs work, and how the structure of LLMs being different from the structure of human speech processing leads to another class of problems that AI is worse at understanding than humans. To start, let's look at a narrow problem that AI is commonly used for: sentiment analysis. Given a piece of text, like an Amazon review of a product, can AI detect if that text is positive or negative? A simple way to start this is to look at every word in English and give it a score for how positive or negative it is. We can give words like awesome or great a positive score, and words like awful or gross a negative one. So in a sentence like, "The price and quality is great, but I dislike how heavy it is," we could have great cancel out dislike and evaluate this as a neutral review. But we'll quickly run into sentences where this won't work. Look at, "The quality was not great." Here, the not should make the value of great negative. But a sentence like, "The quality was not awful," is still negative, even though awful is preceded by not. So we need some more complex ways of processing language to capture this contextual information. The field of linguistics has been working on problems like this for a long time, and has settled on something like a language processing stack they think humans use. I have a whole video on this if you aren't familiar with these terms, though you sometimes see some differences. Like in my video, I kind of conflate phonetics and phonology, which are kind of different things. You could lump pragmatics into semantics, you could include morphosyntax and psycholinguistics, etc. But in general, we think it works something like this. Up to a few years ago, it was common for AI engineers to directly use these linguistics concepts when building their models. You can see here a direct implementation of something called X-bar theory from syntax. But as language-based AI has improved, it's gotten more removed from how we think human language works. Frederick Jelinek, a researcher in this field, is relatively famous for saying, "Every time I fire a linguist, the performance of the speech recognition goes up." GPT models, for instance, use structures like multi-layer perceptrons and attention blocks. These have proven remarkably effective, but are just large piles of machine-optimized matrix multiplications. They no longer resemble actual linguistics at all. This is actually more common than you might expect when you're using computers to generate things. For example, in my last video on generating maps with computers, I used algorithms based on music theory to generate continents. That's obviously nothing at all like what the process actually looks like, but as long as it gives a nicer result, it usually doesn't matter for most applications. Now, of course, modern AI can extract a lot more meaning from a phrase than just the sentiment. Imagine if instead of trying to determine if a phrase was just positive or negative, we also try to determine if it's happy or sad. Now we can extract a much wider range of meaning. We don't just get two values, but we also have meaningful combinations. Positive and sad might be something like bittersweet, a whole new emotion we didn't have to model explicitly. So we can add more of these dimensions of meaning, and the total amount of states that we store goes up extremely fast. Then, instead of explicitly stating what we want each of these dimensions to mean, we can let AI determine what's the most optimal. This is the basic idea of unsupervised learning, AI figuring out for itself what the best way to represent data is. So we end up converting language into a series of numbers that represent meaning in an abstract, high-dimensional space. This is called the embedding space. And once AI has this abstract representation of meaning, it can convert it to different forms. Chatbots use it to guess the most likely next word. Translation software reverses the process and builds back up a sentence, but now in a different language. And image generators use frameworks like Clip to convert from this low-level representation of meaning into an image. And of course, all of this gets more complicated when you're dealing with multilingual input. Instead of starting with a list of every word in English, we have to start with a list of every word in every language. And so, unless the particular AI you're using has been trained on this wide variety of cultural references, it's going to be bad at dealing with multilingual stuff. For example, here's a Google AI trying to talk about my Spotify listening preferences.
We see you rocking out to a lot of what I would call energetic anime soundtrack. One reason, Vibe A by Asian Kung Fu Generation and Bling Bang Bang Born by Creepy Nuts are all big hits for you then.
Believe it or not, this is read Haruka Kanata, not A. Although when you're learning kanji for the first time, that is how it feels sometimes. Now, if we just treat this all as a black box, it's somewhat similar to how we expect human language to work. We get some input, feed it through a bunch of levels of processing it, and end up with some representation of meaning. If we want to translate to a different language, we take that raw meaning and go through the reverse process. That general process is the same, both for humans and AI. But for my pun, it works differently. The specifics of what's happening matters. We start with Japanese text. This goes through the pipeline to be broken down, but as soon as we create the proper sounds, we go, oh, this isn't Japanese at all, I need to interpret this as English instead. It shortcuts the normal translation pipeline and jumps over to the other language immediately. AI has no method of shortcutting like this. It always processes down to an embedding first and then just translating from there. This abstracts away from the sounds being created right away, so by the time it tries translating, the critical information is already lost. That's why if you try this out, you get a lot of AIs trying to convince you that this morning, every morning is funny in English. If it jumps right to the meaning, it's already lost the critical information that makes it a joke. If you look for examples today of how people are talking in ways that AI can't understand, you see a lot of similar situations where the type of communication being used relies on the specific chain of methods humans use to process language that's different from what AI does. A common use for AI today is to look at things like YouTube comments and try to sift through what are things that YouTube doesn't want on its platform and what's content it deems acceptable. People generally don't like being censored in this way, so you can find a lot of creative usages to get around this. One common thing you'll see, for better or worse, is people trying to talk about death without AI picking up on that. One technique for this is to replace the word kill with unalive.
I swear someone got murdered and sacrificed tonight here like 12 minutes ago.
This specifically targets AI's understanding of morphology. There's a process called zero derivation, where we can make verbs out of other parts of speech. Say, going from the noun Google to the verb to Google something. As one of the great philosophical minds of the 20th century once said, verbing weirds language. And while we're reading that, might as well just add the whole collection. So unalive takes the adjective alive and converts it into a verb. Then it adds the prefix un to make it into the opposite of to alive. None of this is standard English, so an AI won't find training data older than a few years, but native English speakers are able to instantly understand what this means. Now, the clip I'm using is not against YouTube's terms of service at all. It's very fine to post a video of you playing Dungeons & Dragons. But the reason they felt the need to try to trick the AI is because they didn't trust AI to understand the pragmatics of the situation. If you're playing a game, saying I'm going to kill someone is very fine. But if you're talking about killing outside of that context, YouTube really wants to try to stop that. And that line can be confusing for a human to determine, much less an AI.
If Cheeseman kills himself, does being a piece of cheese count as artistic context?
You also see phonetics come into play. A recent common way to talk about pornography on the internet is to say corn instead of porn. I bought some corn on those sketchy sites. AI could probably tell you that corn rhymes with porn, but because it's not processing sounds in the same way humans do, it's not going to jump from a word to a word that rhymes with it as quickly as humans will. This kind of thing also builds over time. A great example of this is how you laugh in Japanese. The word to laugh is warao, and when you type it, you use these letters on an English keyboard. So on the internet, if people are trying to spam it, it starts looking like this. And if you're typing really fast, it starts looking like this, and then gets simplified to just W's. You see this a lot if you watch Japanese Twitch streams, for example. When you look at a big wall of W's like this, it kind of looks like a field of grass. So eventually, the term for LOL in Japanese became this, which is the kanji for grass. Now, this has been around the internet for a while, so AI definitely knows to associate the kanji for grass with laughter. But people do this stuff dynamically all the time. The proliferation of Unicode and emoji also means this kind of thing is showing up increasingly often in the English-speaking world. For example, you can probably read what this says, but the Unicode characters I'm using here are not at all associated with Latin letters. So an AI that doesn't have a dedicated computer vision component isn't going to understand this in the same way as a human. At least until enough humans talk about it that it can figure it out from context. And that's part of what makes it so hard to have a discussion about what AI can't do. AI is changing so fast that by the time you're watching this video sometime in the future, all the examples I'm giving might not be relevant anymore. So instead of just talking about what AI can't do now, how can we talk in more general terms about what AI can do in theory in the future? I want to be able to put never in the title of this video without that being clickbait, but as my father often says, forever is longer than you think it is. There are a lot of theories about the future of AI development, some of which are more reasonable than others, but as a rule, people are pretty bad at predicting the future. 60 years ago, pop culture thought we would get artificial general intelligence before the year 2000, and academics aren't much better. This 1970s book claims the odds of the Soviet economy getting worse by the end of the century are very unlikely, while we know it wouldn't even exist 20 years later. One of the reasons for this is that change can often be non-linear. In The Tipping Point, Malcolm Gladwell talks about situations that slowly build without people realizing. Then, once they pass some threshold or tipping point, it seems like they suddenly transform very rapidly. For example, the temperature of water has, at first, no effect on its liquid state. But as the temperature of liquid water rises or falls, a moment arrives when the state of cohesion changes, and the water is converted, in one case into steam, and in one case into ice. That's actually not from tipping points, it's from... oh. Okay, maybe we need more context to quote from this. Anyways, part of why this happens is that a number of physical processes are scale dependent, as in they have different characteristics depending on how big or small they are. GPT-2 and GPT-3 are essentially the same thing, but GPT-3 is a lot bigger, and just that change in size has a very qualitative difference in how good it feels. But there's no guarantees that making it bigger will necessarily make it much better, and it's possible that when the architecture gets big enough, it starts introducing new problems that weren't present on smaller scale versions. Another difficulty in predicting the future are so-called black swan events. Events that fundamentally can't be predicted, but still have a large effect on the course of history. They named this after the black swans that are native to Australia. Before Europeans landed there, they had no reason to suspect swans could be anything other than white. There wasn't some gradient of swans gradually being discovered that suggested eventually a black swan would be found. From the European perspective, one day the sentence, "all swans are white," was correct, and the next day it was incorrect. There's a lot of science fiction books about this kind of discovery, where something totally unexpected changes the course of history. You can also look at real-life events like the discovery of the jet stream. There was no reason to suggest it existed until people discovered it in the middle of World War II. Isaac Asimov writes a speculative future for science in his Foundation series. In it, psychology gets so advanced that it's possible to fully predict the entire course of events for thousands of years to come. Because psychology was this new, interesting field at the time, this kind of prediction didn't feel totally unreasonable. And in the second and third books of that series, they talk about black swan events, things that were fundamentally unpredictable despite all these advancements. But unfortunately for Asimov, the fundamental assumption of this book is also wrong, as within 10 years of him writing this, we would discover chaos theory. The relevant point of this is that small deviations from what you expect can magnify over time, leading things like history to be fundamentally unpredictable. History could even be considered what's called a second-order chaotic system, because even if it were somehow possible to fully predict it,
I can see the future!
that prediction would in turn influence the course of events. Yuval Noah Harari postulated that Marx was correct in his estimation of what capitalism would entail, but capitalist leaders also read Marx, and therefore changed their policies to get the modern welfare state, something Marx didn't predict. See, I knew these would be relevant. And this is especially relevant for this conversation, because AI trains on discussions that happen on the internet. So anything I point out in this video that AI is bad at understanding will inherently make AI better at solving that problem. And by bringing attention to the flaws of current AI, it also makes current AI developers more likely to address those problems. So given all that, are there things we can definitively say AI will never be able to understand? In my opinion, we can. But to do so, we're going to need to talk in more general terms than the specifics we've been using so far. The general takeaway from part 1 was that AI has less context for communication than humans do. I showed that you can give AI more context, but there's always going to be a limit to that. Some of the largest books you can buy today are around 500,000 words long, and that's already longer than the context windows for most large language models. Now, AI engineers are of course aware of this, and already have systems like RAG that allow AI to reason about things outside of its context window, but there's always going to be a limit to that. Let's see modern AI try to read House of Leaves, for example. Certainly you could design an AI that incorporates some visual processing and text processing together to get some kind of read of what's going on here, but then I can just come up with a new example that doesn't work for that framework. At the extreme end, we have stuff like visual meaning. Most people will agree that this image is scarier than this image, but we certainly couldn't tell you why. And this kind of thing is cross-cultural. Like, look at these two images. One of them is named Kiki, and one of them's named Boba. Which would you call which? It turns out people across cultures and languages generally label this one Kiki and this one Boba. There's nothing inherent in the meaning of this image that would say that. It's dependent on the specific processes that humans generally share on how they process information in language. So even if AI has the same data and can generally come up with the same results, in situations like these, it's not going to be able to understand what's going on unless it processes that information in the same way as humans. And that's something AI will never do. AI, after all, stands for artificial intelligence. If it's processing information the same way as human intelligence, it's just human intelligence. It's by definition no better. This general argument is called maps versus territory. A map is just a representation of actual land that exists out there, and usually just having a map is good enough. But there will always be things that a map can't tell you, and you could find out from being there in person. If I say, oh, the store is just downhill from the market, you can't tell what direction that is on this plain map. You could draw a different map that would give you that information, but then I can say something like, take a left at the place with the blooming cherry trees. And now, again, that's not going to work unless you add more detail to the map. At the extreme, you could conceptually create a map that's a one-to-one scale model that perfectly matches and simulates reality. But at that point, the map has no use. If to figure out directions on the map, you have to physically walk from one point to another, you might as well have just done that in real life and saved all that cost. Maps, definitionally, will always be simpler than the territory they represent, because if they're not, there's no point for them to exist. So even if, say, we have a machine that can fully comprehend language in the same way that a human does, if it doesn't have the same model of building a language, there's going to be some fault lines in that. It won't adapt to when the language evolves in the same way a human does. Even if it's a perfect representation of a human in every way, but faster to build, it's not going to truly be able to discuss something like what it feels like to learn a language. A perfect representation of how a human works is by definition no better than an actual human. So all the specific examples that I gave in part 2 may not be accurate in the coming years. But the general logic, AI not understanding things that are dependent on the specifics of how humans do language, will always be correct. There's a plot element in the third book of the Three-Body Problem series that exemplifies this. Humans are trying to communicate with each other in a way that aliens won't be able to understand. So they communicate in a way that depends on the specific differences between how humans process information and the aliens. Even though the aliens are much smarter and technologically advanced than the humans, they still have things they can't understand. So while AI in the future might be able to understand all the examples that I gave, there still will be new things that it can't understand, based on those differences that have to exist between how it thinks and how humans think. The postmodern philosopher Jean Baudrillard would describe it this way: that AI is a simulation of language, and simulations will always have simplification over the reality they're representing. He talks a lot about simulations and their role in media and society, and I think applying his work to AI can give us some very helpful insights. It can give us a third thing that AI will fundamentally never understand, no matter how it advances, and can also shine a light on one of the dangers of AI that I think people generally aren't talking about enough: the danger of AI conflating simulations with reality. Okay, so here's the basics of Baudrillard's simulation theory. There are real things, then there are simulations of those things. Simulations in some way represent the real thing, but are simpler, just like we talked about with maps and territories. Simulations ideally are accurate to the thing they're based off, but aren't always. For example, me explaining this philosophy to you is a simulation. I read it and am presenting a simplified form in a different context to you. You would hope that what I'm saying is accurate to the real philosophy, but there's a variety of reasons it might not be. Some of those are innocuous. I might have just misunderstood it, or I could be trying to modify it slightly to fit this context better. But I could also be intentionally misrepresenting it to you. For example, I get a percentage of the ad revenue from this video. So in addition to accidentally misrepresenting the truth, I could be intentionally misrepresenting the truth in order to optimize watch time and make more money for myself. As a consumer on the internet, you should be watching out for when something is accurately representing the truth and when it's not. And when it's not, you should be thinking if it's not representing it for an accidental or intentional reason. Is the simulation trying to manipulate you by being inaccurate? But of course, in real life, things get a lot more complicated, as simulations can quickly get layered on top of each other. Like, I'm also not actually reading Baudrillard, I'm reading an English translation. That translation is a simulation of the actual words he wrote, and therefore could be, intentionally or not, misrepresenting his real ideas. If you talk to a friend about this video, we now have 3 layers of simulation that all could be distorting the original in different ways. Now, as that simulation gets distorted more and more, it eventually stops representing the original at all. At this point, it's called a simulacrum. a simulation of a thing that doesn't exist. And simulacrums are dangerous because, from the outside, they look the same as simulation. Their very existence makes us question whether any simulation is accurate to the real thing or not. And because they have no reference to ground truth, they can be more easily manipulated by various third parties. Now, this is all intentionally phrased vaguely so it can apply to a lot of different things. And because we're talking about what's fake and what's real, it can be hard to talk about things this applies to really well because they start getting political and messy. One of Baudrillard's book on this, for example, was called The Gulf War Did Not Take Place, which is about the most clickbait title I've ever seen for a philosophy book. But anyways, the point is, I think it's helpful to look at fictional narratives because at the end of a story, we all have the same answer for what was and wasn't real. So with that in mind, I want to walk through the plot of the 2002 show Ghost in the Shell Standalone Complex. In the distant year of 2024, an act of terrorism is committed against the executive at a major pharmaceutical company.
If your word means anything, then talk, damn it!
Now, this criminal hides his name and face and isn't very clear about his ideology. So right away, we get a simulation of what this actual crime was. The public perception of the event that may or may not be accurate and is already being distorted.
Some rumors say that those graphics were changed after the initial broadcast.
After this first crime, there's a series of other crimes that copy the concept of the first one.
Hot on the heels of Serrano, Japan Micro Industries has apparently been blackmailed by the notorious Laughing Man.
This qualifies as an unprecedented act of corporate terrorism.
These crimes act like they're committed by the same person, but really they're copies of the public perception. They're 2 steps removed from being real, and kind of are their own unique thing at this point. It eventually comes out that these crimes are, in fact, fake crimes that are only designed to manipulate the stock prices of the companies involved.
What about the rumors that each of those companies had people who secretly made a killing off their stocks?
And this is what I meant by simulacrums devaluing the originals. When you learn that one crime was faked and wasn't real, it makes you question all of them. If I can prove that these ones were faked, I'm not going to have any confidence that that first one actually happened.
What if the Laughing Man turns out to be a program that the entire micro machine industry wrote and staged so they could manipulate their own stock market prices?
6 years later, someone shows up claiming to be that original person and now threatens to kill a police administrator.
If you put on another performance that rings as false as this one, I will be forced to remove you from the stage.
So, was that the original person who committed the crime, someone who committed one of the copycat crimes, or a third person that's new to all this? And if it is a new person, are they copying the original crime that took place, or the public conception of that, which is different? Really, at this point, it's a simulacrum. It seems like it's representing this original crime, but at this point it's so many steps removed, it's a totally unique thing.
Phenomenon created by copycats with no original.
The plot of the show, then, is trying to track down the actual sources of truth and stop these crimes from happening. But all these layers of simulation and simulacrum make it incredibly difficult. If you can find the motives of one person, is that actually their motives? Or are they simulating a different crime? If you think some information is being manipulated and isn't representing the truth, is that happening for an innocuous reason? Or is there some third party that's trying to manipulate everything to get their own ends? We think the corporations are manipulating things, but maybe the government is manipulating those corporations to manipulate the facts of the situation. It all gets really complicated really fast.
All of these upstanding people who couldn't possibly be linked to the Laughing Man crimes, with no trace of external manipulation by a virus or brainwashing device, committed an act of terrorism simply because they saw a warning on TV insinuating that the Superintendent General would be assassinated.
And, of course, at the end of the day, this is a cyberpunk thriller series, so we have to have some cool mech gunfights. The second season of the show also features a simulacrum, but this time it's about political ideology. A number of terrorist groups show up that all claim to be inspired by a piece of political writing called The Individual 11. But it turns out that this political writing doesn't actually exist. They all have an idea of what it is, but there's no actual thing they're referring to. So it's impossible for the government to ever meet the demands of these terrorists because their demands are nebulous and not based on any real thing. They're fighting against a nebulous ideology, and so no concrete action can stop them. We eventually learn that various other interested parties are using this fact to manipulate this group to their own ends. The ideology's lack of specific reference points, both making it harder to argue against and making it easier for the individuals following this ideology to be manipulated. Again, thankfully, this is all a cartoon from 20 years ago and has no basis on anything that could happen in real life. People following political movements based on ideology have definitely read the things they're referencing. Anyways, the point being, this exemplifies the second danger of simulacrums. Because they have no basis on real life, they're nebulous and can be manipulated. Okay, so hopefully you've been thinking about how this all applies to AI. First, when AI is working well, it's a simulation. So an AI summary of some text is a simulation of that text, and an AI chatbot is a simulation of real human conversation. That simulation can become divorced from the truth, both for unintentional reasons, like AI hallucinations, or intentional reasons, like prompt injecting or intentional design by the creators of the AI. So at best, AI is a simulation of language, and at worst, it's a simulacrum of one. And it's always trying to act as close to a human as it can, so it's intentionally obfuscating the fact that it's an AI, making the simulacrum harder to identify. But for me, what's more interesting is how AI interacts with simulacrums. Say we have a movie, and then the internet discourse about that movie gets so distorted that it is no longer talking about the movie at all. How is an AI able to tell if this is talking about the movie or not? As a real person, I can actually watch the movie and realize that none of this is talking about the movie. Or I can talk to someone I trust that I know has seen the movie. But all an AI has to go on is what it sees on the internet. Simulacrums, by their nature, are hard to tell if they're real or not. And an AI doesn't have the tools that we humans do that allow us to disambiguate them. AI can never read the original book, can never talk to a person who was actually at an event. It can never look into the business model of someone communicating something. And so I think as AI gets more and more incorporated, both as something making and consuming things on the internet, it's going to be increasingly dangerous how it interacts with these simulacrums. AI misunderstanding if people like Morbius isn't really a big deal, but I'm a lot more concerned with how AI will deal with rhetoric about events like we saw in Ghost in the Shell. It's really important in the modern world to, some percentage of the time, dig down to the ground truth of what's being referenced. Heck, the first line from Baudrillard's book is a quote from Ecclesiastes, but if you go and get Ecclesiastes, you'll find it doesn't actually exist, which is, of course, blasphemy, too. Hi there, joke explainer here. So this French book quoted from the book Ecclesiastes, which is of course named that due to the Latin transliteration of the Greek translation of the original Hebrew. Now, I have a copy of the Protestant Bible, which includes the Jewish Ketuvim, which includes the book Ecclesiastes. Traditionally, making your own additions to Holy Scripture is considered blasphemy. So I say, this is blasphemy too, then I play a clip from this Japanese show where a British boy named Dio says Kono Dio da. Now, in the context of the show, this is usually translated to English as it was me Dio, but a more literal translation would be this Dio. The British boy is of course named after the American metal band Dio, which also means God in Italian. So, I guess I'm just trying to say that it can be hard to find the original context for a thing. I think that's where we're going to end this discussion for today. There's certainly enough reading material if you want to come to your own conclusions beyond this. In summary, I think there's three big things that AI will never understand no matter how it advances in the future. It'll have some lack of understanding based on not having the context for the communication, some lack of understanding based on how it processes information differently from humans, and some lack of understanding from being unable to drill down into simulacrums and tell what's real and what's not. No matter how AI changes in the future, I think we can be relatively confident all of these issues will show up in some form. And so, as AI gets better and better and more integrated with society, it's important that we pay attention to these things. Think about the context for communication. Learn about how human language works and how AI is currently working. And try to, some percentage of the time, dig into things you see on the internet to get at the underlying truth. Don't just take my word that all the things I said were in these books actually are. If you're able to, I really recommend supporting YouTube creators on things like Patreon. Directly funding things being made can help reduce the distortion you get from sponsorships and ulterior motives. I, of course, also have a Patreon, so, take everything I'm saying with a grain of salt, but I'm just trying to thank the excellent people who have sponsored me. I generally end videos by giving some recommendation that you can check out, and if for some reason you don't have enough of those already, I really recommend checking out the book Seeing Like a State. It's a lot of similar concepts to what we talked about here, but focusing on society and big government planning. Reading this book while thinking about context and simulation is pretty insightful. And if you're wondering why I have a 1970s book about Latin American political development, that's coming up next video. I'm planning on doing some historical simulations of governments, which I think will be fun. Thankfully, there's not a big reading list for that kind of thing. Oh.